So let's send this. I already have the request here, so I just send it to the repeater and play with it on burp directly. So if I send, I indeed get the entire file right in front of me. So what are the users we have here? We have a bunch of them. We have Indie Shell here, who has bin bash like root. We have administrator, who is apparently running PostgreSQL. Do we have like access to that? I'm going to ls the content of that file or folder and redirect the output to t.txt. Oh, sorry, hello.txt. Yeah, 9.3, etc., etc. That would be very lame to start, digging using that web shell. I'm going to try to receive a reverse shell. So I'm going to expose a local port using ngrok, and I'm going to take that host and port, generate my reverse shell. It's just taken from Pentester Monkey, and I'm going to listen on that port 8443, and let's run that command right here. If we send it, do we get something back? Nope. Oh, what a bummer. We don't have a reverse shell? Well, I think we're stuck with this lame shell. Anyways, so remember from our first enumeration in the first episode, we had Tomcat. So I'm going to find the file that has the name tomcat users.xml, and I'm going to put that into our hello.txt file. I just want to read its content. With some luck, we might be able to edit it and enable the administration dashboard. So if I see the content, I just forgot to specify the location. It's taking some time because it's trying to find it on the system. And if we see the results, we can indeed copy the file and see what we have as permissions to access it. So it's owned by root and Tomcat, but we don't have access to it. We can't even read it. What a bummer. Okay, well, what can we do other than that? I think we're stuck with some enumeration to do. So let's rerun the find command with this time suid bit, and let's put the result into hello.txt. Let's send it. We have a bunch of things here, things that we've seen in many previous videos, but do you notice something different here? We have a script or an executable, I don't know what it is, opt whack-s. I wonder what this is. Let's use the file command to learn more about that file. So it's a ELF 32-bit executable. All right. Can we edit it or something? I'm not sure. Let's just use ls. Nope, we can't edit it, but we can run it as root and we would have root privileges. But this is a big hypothesis because we need to find a vulnerability in this script. So let's first run it and see what we get as output. Starting copy of root user files. Ooh, that's really interesting. It looks interesting. Let's see if we have any other output here. Yeah, we just have this output. So it's starting to copy root user files, but what is doing exactly? With some hope, we might be able to find something in the strings of this binary. So if we fetch that file, we have a bunch of things right here. But do you notice anything that pops up? Yes, we can see that we have the exact command right here. It's copying using the SCP, the entire folder under root, all folders under the root directory to localhost on var backup. Okay, let's verify if we have anything under var backup. As you can see, we don't even need a reverse shell. We are trying to do what we have to do, but it's not always mandatory to have a web shell, a reverse shell, I mean. We have nothing under that folder, var backup. Okay, what did we have before? So it's trying to copy that folder, but do you notice anything vulnerable here? If you've seen my previous video about privilege escalation, you'll be able to answer this question. So basically we're using SCP here without an absolute path, which means that we can define our own version of SCP. So here's how it will go. Because we already have port SSH open, the content of the script or the malicious SCP file would echo the content of my public key to root.ssh.authorized keys. Well, before that, I just want to make sure that we create that folder .ssh. So the script would create the folder if it doesn't exist, and then we'll echo the public key, which I'm going to put right now, to authorized keys file. That way I will be able to SSH into the server as root, hopefully. So just going to grab my public key. And by the way, you can generate your own key using ssh-keygen and specify the name. We don't want a passphrase, and it will automatically generate this for you. And the public key is this one. Well, we can use that, or I can use my own that I generally use in CTFs. So I'm going to copy that and I'm going to paste it right here. We're going to echo that and put it in a file that we can name SCP. Okay, let's send this. And do we have the file SCP now in the web root? Yep, so this is our script. Make the directory and then echo that and redirect it to our file. Now you notice that we have spaces here, and that's because we haven't encoded our payload. We need to encode it properly in order for our script to be copied. So I'm going to take that part right here and Control U to encode it. Send it, and if we retry now, we can indeed see that we have the correct formats. So with that said, we will define a new path value environment variable that will contain our current directory, which is var ww. So I'm going to say, hey, path would contain the content of the old path value plus, I will start with the value of pwd, my current directory, and then append the old value. And after that, I'm going to run opt/s. That would allow me to force the script under opt/s to load my path environment variable and look for the SCP executable under the current directory. So I'm just going to redirect the output to hello.txt and see what we get. So it's just printed the normal output of our script, starting copy of root user files, but instead of copying them, I guess that our exploit, if we're lucky, would work. Now, let's verify that with ssh ctf29.rootme.org with the root user. Let's accept the fingerprint, and it doesn't work. I might have done a mistake right here. So that redirection, I'm going to use T command instead of a redirect. And let's rerun our command. And after that, I'm going to execute my final attack. Now, if everything goes well, we should be able to SSH. So what do we have under SCP? We'll echo the content to root SSH authorized keys. Yeah, we need to change the permissions of our malicious SCP to executable in order for it to be executed. Let's send it. And now with our third attempt, let's retry to SSH. And we are in. Perfect. So if I go